So now that we know how to take derivative of exponential functions, or the natural exponential function, well, let's do the natural thing and integrate it. The cool thing here is obviously if d dx of e to the x is e to the x, then the integral of e to the x is also e to the x. Now, if x is actually some function u of x, then what I need to have this antiderivative is u prime of x out here. So if I have the integral of u prime of x times e to the u of x, that's going to be equal to e to the u, where again u is a function of x, plus c. This constant of integration, because this is an indefinite integral. Both of these are indefinite integrals. So let's take a look at a couple of examples here. I have 2 times e to the 2x minus 1. Now, I'm going to approach this with a straight u substitution, just like we did some time back. So I'm going to say let u equal 2x minus 1. That means that du equals 2dx. Now, that's exactly what I have sitting here. So this gives me the integral of e to the u du, which is, well, e to the u plus c. But u, we said, was 2x minus 1, so the solution is really, this gives me e to the 2x minus 1 plus that constant of integration. Now notice if I take this derivative, I will get the 2 out front that I started with, and this derivative of c, because it's a constant, is 0, so that's just going to go away. Let's take a look at another example here. Here I have e to the 5x plus 1. What I really need is a 5 out here, but I don't have it. But that's okay. I'm just going to go about it like I normally would with the u substitution. So if I let u equal 5x plus 1, that means that du equals 5dx. Well, I don't have a 5dx, but I have a dx. So that means that du over 5 is equal to dx. That's what I have sitting here. So this is going to give me 1/5 times the integral of e to the u du, which equals, well, e to the u, the antiderivative is just e to the u. So this could be e to the u over 5 plus that constant of integration. But remember we said u was 5x plus 1, so that actually gives me e to the 5x plus 1 over 5 plus this constant of integration. Now again, you can double check this simply by taking the derivative of this, and if you do take the derivative, you will get this piece right here. You get that back.